Hey, in the diagram below, the points 0, 0, and that's the origin, and A, 8, 6 are fixed. The angle OPA varies at the point X, 10, moves along the horizontal line Y equals 10. Okay, so like this angle is changing as this guy slides this way or this way. It says show that AP is this, is equal to the square root of x squared minus 16x plus 80. Okay, so I see 2 points in the coordinate plane. I'm trying to find the distance between those 2 points, and AP is in a structure that looks very much so like the distance formula. So I'm going to pull out your old faithful friend, the distance formula, and I'm going to figure out what AI should be. So, or AP, sorry. So AP is going to be equal to the square root of, this is the first x minus the second x, square it, plus this is the first y, and then this is the second y, and you square it. So now we're going to simplify. And I have x minus 8 squared. I'm going to have to distribute that in order to be able to combine it with this guy. So I've got x squared minus 16x plus 64. And then this is going to be plus 10 minus 6 is going to be 4. Squared is going to be 16. So now I have AP is equal to the square root of x squared minus 16x plus 80. Boom. I says write down a similar expression for OP in terms of X. So now OP is this guy, and similar meaning you should use the distance formula as well. So now I've got OP is equal to the square root of, and then this is the first X, this is the second X. So I'm going to do X minus 0 squared plus, and then I've got, oh, sorry, I'm going to start with this and then go to there. Yeah, so that way they're both positive. 10 minus 0 squared. Okay. So then now I have OP is equal to the square root of x squared plus 100. That's it. All right, cruising along. B, hence, show that the cosine of OPA, so remember this is OPA, and the cosine of that guy is going to be equal to this. This comes right from the law of cosines in your formula booklet. So let's try to figure out how we would write this. So I've got the cosine of A, or OPA in this case, is equal to, and then I've got B squared plus C squared minus A squared all over 2BC. So this is going to be the side that is across from OPA. And then I've got B is going to be my first side and C is going to be my second side, okay? The way that I'm going to find that other piece is 10. It's going to be 10. Okay, so I'm trying to figure out what this would be, the side across from OPA. And I just was like, okay, I'm going to do, what's it called? The distance formula between these 2 points. So I got to do the square root of, this is my first x, I got 8 minus 0 squared plus 6 minus 0 squared. And I'm like, all right, yeah, okay, I see. So it's going to be 64 plus 36. It's going to be 100, and then it's going to be 10. Okay, cool. So now I have all my stuff. This side, let me just label them x squared plus 100. This helps it, makes it easier to sub it into the formula. Okay, so then now I've got the cosine of OPA is equal to, and I've got the two sides here being squared, so I got the square root of x squared plus 100 squared plus, this looks nasty, area x squared minus 16x plus 80 squared minus, and then this is going to be 10 squared. This is all going to be over 2 times b, which is going to be x squared minus 16x plus 80, oops, times the square root of x squared plus 100. Okay, cool, cool, cool. So is that what I ended up getting? Wait, or what did they end up getting? Yeah, this whole thing is under the square root. Okay, cool. The only thing that doesn't match is that I have an extra 2 somewhere. How come they don't have a 2 over there? I'm gonna have to combine, aren't I? Ugh, okay. That's all right. You see what I'm saying? I'm like, okay, I have a 2 up down here, and there's no 2 down there up there. So I'm like, all right, I'm gonna have to distribute. Okay, so I've got the cosine of OPA is equal to, and then I've got x squared plus 100 plus x squared minus 16x plus 80 minus 100. Okay. Cool, 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 cool. And then x squared minus 16x plus 80 times the square root of x squared plus 100. Okay. So these are going to cancel. And I will be left with 2x squared minus 16x plus 80. Oh, this is fabulous. I can factor out a 2. So I have 2, and then I have x squared minus 8x plus 40. Perfect. Oh, these are going to cancel. Excellent. Okay. Oh my goodness. There's really no room. Okay, that's fine. X squared minus 8x plus 40 over the square root of x squared minus 16x plus 80 times the square root of x squared plus 100. Okay, we are there. Hallelujah. We did it. I need to find in degrees the angle OPA when x equals 8. This is a wild expression. I'm typing this into my calculator because I don't want to be evaluating this thing. So I'm going to type in x squared minus 8x plus 40 all over the square root of x squared minus 16x plus 80. Then just keep in mind that this equation returns the cosine of an angle that we're looking for, okay? It doesn't give us an angle measure. So I'm looking at the question that it's about to ask me, and it's telling me that I'm going to evaluate this thing when x is 8. However, also make sure you're in degrees. I'm going to evaluate this thing when x is 8, but just keep in mind that that's going to return a cosine trig ratio for me. Okay, so this is the cosine trig ratio. I need to inverse cosine it to get the angle. Okay, so angle OPA when x is 8 is going to be 38.7 degrees. Why is there like a line here? It's weird. This like won't erase. Okay, whatever. Not a problem. Okay. Okay, and then it says find the positive value of x such that OPA is equal to 60. So remember, if we're looking for 60 degrees, we don't just set the whole thing equal to 0. This returns the cosine of OPA. So we need to find the cosine of 60, and then we'll set the whole thing equal to that, okay? So the cosine of 60, that's a common trig ratio. We know that that one's going to be 1/2. So I'm going to set this whole thing equal to 1/2 by graphing a horizontal line of 1/2. And then this is like a very funky window, so I think I'm going to need to find the positive value of x. Okay, so the positive value of x, so that means I'm going over into the positive part, and it looks like there's a negative solution here, and then there's a positive solution over here, so I'm going to find that positive solution. That's what they mean there. And it is 5.63. All right, cool. So I have x is equal to 5.63. And I would just like give a little sketch of the curve, maybe like this is cosine of OPA equals, and then I have this piece above, and then there's a horizontal line that is passing through. I guess here, yeah, and then that would be 5.643,634. Okay, so that's how we found our answer there. Just to give a little sketch to whoever's grading, and then okay, let the function f be defined by f of x equals the cosine of OPA, and then we have our function that we have graphed. And it needs to be on the interval from 0 to 15. It's weird, but okay. All right. It says consider the equation f of x equals 1. So now we have a horizontal line, f of x equals 1. Explain in terms of the position of the points 0, O, A, and P why this equation has a solution. Okay, so let's go back and look at the original diagram. So O and A are fixed points, and then P just kind of slides back and forth between the two. And as P slides back and forth between the two, the cosine ratio over here changes, but it is always sandwiched between the outputs of -1 and 1. So the range for cosine is between -1 and 1. O stays at the origin. P slides back and forth between O and between 0 and 8, right? Look at the picture. Slides back and forth between 0 and 8. So when the cosine of OPA equals 1, it is the maximum angle. And you can see that because look at the graph, right? F of x equals 1 is going to hit right at the maximum of the blue graph. And when does that happen? Because it says find the exact solution to the equation. So let's go ahead and see what the solution would be. Hello. So we're going to find the intersection of these 2 points here, and it's 13.333333 repeating. So let's take that 13.333, and what would that look like? That's 13 1/3. So let's take 13 and rewrite it with a denominator of 3. And that's going to look like 40 over 3. So the exact solution is going to be 40 over 3. X equals 40 over 3. And 40 over 3 looks like 13.33333, which we found on the graph.